Perfect squares, perfect cubes, and their roots. So here's a Rubik's Cube, and slow it down a little bit here. What is the edge length? Are you okay if we say it's 3 units because there's 3 squares along the edge? The area of one face then would be 9 units squared, and the volume would be 27 units cubed. Because it would take 27 of those little squares to add up to the whole thing. There's 3 rows of 9. So we call the number 9 a perfect square because it's 3 times 3. We call the number 27 a perfect cube because it's 3 times 3 times 3. So you can take out your highlighter here. Any whole number that is the area of a square with a whole number side length makes a perfect square. So this idea of calling it a perfect square is actually because you can make a square. And if I put whole numbers on the side, like 4 and 4, then the area would be 16. So we call 16 a perfect square because you can square root it and because it's 4 times 4. Recognizing these numbers and knowing how to do mental math with them will be very important moving forward. So do you know when you see 81, do you know that that's 9 times 9? Probably 100 you know is 10 times 10. Can you recognize these perfect squares? If some of them you don't recognize, then I would say make sure that you're studying these numbers and thinking about them, going through all of your perfect squares. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Having that ready for you for mental math, because that's going to help you in this unit and some of our subsequent units as well. We know how to square root. This is the square root sign, and if you get square root of 25, you are looking for what number multiplied by itself is 25. So the square root of 25 is 5. It is like saying you have a square and the area is 25. What would be the side lengths? They would both have to be 5 and 5. A perfect cube, oh, I like highlighting. Pull up my highlighters. Any whole number that can be represented as the volume of a cube. And we saw this with our Rubik's Cube at the beginning. If you have a side length of 3, then the volume will be 3 times 3 times 3, 27. That makes it a perfect cube, and I just noticed in my list, we have to, let's do it this way. You have to add 27 in there because it's missing. Right? Because 2 times 2 times 2, that's equal to 8. 3 times 3 times 3, that's equal to 27. 4 times 4 times 4, that's equal to 64. So these are our first perfect cubes. We just have to add 27 to that list. And the cube root, which we write like this, like the square root, but we put a tiny little 3 in there to say cube root, Fourth root would have a tiny 4, fifth root would have a tiny 5. That's saying if you knew that the volume of the cube was 125, the only way that would be possible is if all the sides were 5, because 5 times 5 times 5 is 125. And we write the cube root like a square root, but with a tiny little 3. Do a quick check on your calculator. Can you find your square root button? Can you type in square root of 25? Does it give you 5? Can you find your cube root button? Can you type in the cube root of 125 and get 5 as well? So you could find the square root of 1296 with the calculator by just typing it in. But if this was on a non-calculator part of your test, we're going to use the prime factorization to help us figure that out. So what does that look like? Well, if I have 1296, I hope you can see that you could divide it by 2. It's going to be 2 times 648. We can also then break up 648 as 2 times 324. So if you use this strategy of, if I have an even number, I can just keep dividing it by 2 or cutting it in half. Now the 324 is 2 times 2 times 162. And this is not a bad strategy to use until you get a number that's actually on your times table, like 81. Two times 2 times 2 times 2 times, and then you can break up 81 to 9 times 9. And each 9 is 3 times 3. So there is our prime factorization. We broke it all the way down. Maybe I'll label this. Once it's broken all the way down, we have our prime factorization. Now, if you wanted to square root 1296, the idea is 1296 has to be something times something in order, and those two numbers would have to be the same in order for us to square root it. So if I want to do the square root of 1296, it would be one of those. When we do our prime factorization, the question becomes, can I split that up evenly so I have the same number in each bracket? In other words, if I put a 2 in this one, I'd have to put a 2 in this one in order to keep them equal. Do you see that we have 4 2's? In order to break that up equally, there would have to be 2 2's in each one. And in order to split up the 3's equally, there would have to be 2 3's in each one. And then if you multiply out, maybe I'll just, before I do this line, I'll take one extra step here. If I multiply those out, I get 36 times 36. And so therefore, the square root of 1296, if 1296 is 36 times 36, then the square root has to be 36. And we could use our prime factorization to do this without a calculator. If you had a calculator, make sure you can type in the square root button on your calculator and get square root of 1296. If you don't know where these buttons are, make sure you take some time right after class during break. Come bring your calculator and say, how do I do this on my calculator? Because each calculator is a little bit different. And we can use this same strategy to find a cube root without our calculator. Again, if you have a calculator, you would just type this in. The cube root. For those of you with a graphing calculator, if this is new for you, I'll quickly show you where the square root and the cube root are on the graphing calculator. The square root button is on my calculator, it's blue, which means I have to go second square root, and we can double check if we got that first one right. Square root of 1296, 36. Perfect. For the cube root is under math. So if you hit the math button, the cube root is there, and any other root is right after that. So if I do cube root, what do we have? 1728, is that our number?
Yes.
Yes? Should be 12. If we do everything right, we should get 12. Okay? Cube root of 728 is 12. Ooh, reminds me of a number story I'll tell you afterwards. So, cube root of 1728. I would start with 1728. I see that it's even numbers. I know I can cut it in half. I hope you get really good at cutting things in half. You're going to get 864, which can get cut in half again. 432, which can get cut in half again. To be 216, which can get cut in half again, which is 108, which can get cut in half again, 54, and that can get cut in half again, or you could change it to 9 times 6. So sometimes when numbers get into your 10 times table, you might want to change it to 9 times 6, because then you're usually one step away from being finished. 9 is 3 times 3, and 6 is 2 times 3, and now we have our prime factorization done. If you want to find a cube root, then 1728 needs to be 3 things where all of them are the same. Okay? How many 2's do we have in the prime factorization?
6.
6 of them. So if I wanted to break those up evenly, does that make sense that there would have to be 2 in each? That makes 6 of them. How many 3's do we have? 3 of them. There would have to be 1 in each. All 3 of those are the same. If I multiply them out, I get 12, so the cube root of 1728 is 12. Now, obviously, if you have a calculator, using your cube root button on your calculator is a lot faster, but maybe not as much fun. So I think there's some there's some sort of beauty in the fact that you'd be like, I can do this without my calculator, and I could figure this out without my calculator. There's some sort of enjoyment with that. For sine and cos and tangent, it's sort of like, well, I have to use my calculator because there's a lot of decimal places, and there are ways to figure out some of them without your calculator, but you actually have to learn a lot of math in order to do a lot of those. You're going to, by grade 12, have a set of them that you can do without your calculator. Like you're going to be expected to know that sine of 30 degrees is 0.5, and sine of 60 degrees is the square root of 3 over 2. And you can figure those things out without your calculator. So the more that we can do mental math, the better. But it is sure nice to have calculators to figure things out as well. Oh, I was going to, this is very close to a very cool number that has an interesting story. So I will tell you a little story about 1,729. And this story, oh, I should get more facts really down pat. I think this story takes place maybe about 80 years ago, 70 or 80 years ago. And what had happened is they had found a mathematician in India who decided just to learn on his own and was making all sorts of mathematical discoveries. And this mathematician sent some of his discoveries to universities in England. And a professor at that time, and I'm going to probably butcher some of these names, but the professor in England, his name was Hardy, and the mathematician from India was Ramanujan. That's probably not said quite right. That I should work on this one. Anyways, the mathematician, the University in England decided to have the mathematician from India travel to England to study. And the story is that the first time that Hardy and Ramanujan met, Ramanujan arrived in a cab, and the cab number was 1,729, was the license plate or the number of the cab. And Hardy says to Ramanujan, oh, nice to meet. It's unfortunate that the first number that we meet isn't anything special. And Ramanujan responds, actually, it is quite special. It is the very first number that you can represent as the sum of two cubes in two different ways. What he was saying is that you can show that 1,729, it happens to be 10 cubed, which is 1,000, plus 9 cubed, which is 729, makes 1,729. It also happens to be, and this is why I remembered the story, because we just did 12 cubed, right, was 1,728, plus 1 cubed would be 1,729. And it's the very first number where you can do this with cubes. Which then begs the question is, what's the second number that you can write as the sum of two perfect cubes? That would be something to Google. But these are kind of things that as soon as someone finds one, like I mentioned the perfect numbers to you guys the other day, right? We had 6, we had 28. Did anyone find the third one? No, not yet.
600 something.
600 something. So that's how you write 600 something. You kind of make a 6 and then make it messy so no one really knows what you mean. We'll have to find it a little bit more exact than 600 and something. Okay. We have a square. And now we've introduced algebra. The area of this square is 144x squared y 6. And we need to break that up so that you can find a side length on both sides. In other words, we need to write 144x squared y to the 6 as two different things with the same numbers in each of them. Now, if it was just 144, I would hope with your times table you'd see right away what the numbers are. What times what is 144? 12 times 12. So we can do that already. We get 12 times 12. Now we're going to go a little bit back to your algebra from grade 9. If you have an x squared, does it make sense that you would have to have x times x to get an x squared? And what times what makes y to the 6? Do you remember your exponent rules from grade 9? That if you had y cubed and multiplied it by y cubed, oh, I love reviewing stuff. Do you remember this exponent rule from grade 9? That if you multiply exponents, you just have to add the exponents together. That y cubed times y cubed is going to be y to the 6th. Okay? Now that's a rule, and if you just memorize that rule, you're going to run into trouble in math at some time, because memorizing rules without understanding them is going to cause you mathematical difficulties sometime in the future. If you understand, like, if you really think, well, what does an exponent mean? Y cubed is repeated multiplication. That's what an exponent means. And this is repeated multiplication. Does it make sense that I have 6 y's all multiplied together in the end? That's why you can just add the exponents and get a y to the 6. So the side length of this square has to be 12x y cubed. So not only can we do questions with numbers, we can add algebra as well. So many cool things. If you had 125 x to the 9y cubed, think about the number first. Is 125 a perfect cube? Was it on our list of perfect cubes? Yes. 125 is a perfect cube. It is 5 times 5 times 5. Again, if you don't remember that, you could break it up with prime factorization and say I can divide 125 by 5 and get 5 times 25, which makes it 5 times 5 times 5. So I can break up the 125 to 5 times 5 times 5. With your exponent laws, how many x's would have to be in there to make 9 of them? Okay? 3. 3 here, 3 here, 3 here. You could actually, if you wanted to, you could do this. Okay, we've already figured out the 5. You could write your x to the 9 out as 9x's all multiplied by each other. And then you could say, oh, so I need 3 of them, 3 of them, and 3 of them to go in each of these. Right? But I'm hopeful that you can start to do it without having to write it out. Because if I give you a question that instead of 9 has something like 51, I don't know if you would want to write out 51 x's and split them all up. 51 divided by 3 is this question. And with 3 y's, that's a little bit easier. There's going to be 1 y in each. So then the side length of that cube will be 5x cubed times y. So we get to practice some of our algebra skills from grade 9, some of our exponent laws from grade 9, our mental math from previous years, and this idea of what makes a perfect cube. So you would now know that if you were asked this question, what is the cube root of 125 x to the 9 y cubed, the answer would be 5x cubed y. So add the y's in there. So I complete that as well. And basically what you're doing here is you're separating your work up into, I'll do the number by itself, and then I'll do each of my variables by itself. The cube root of x to the 9 would be x cubed. The cube root of y cubed would be y, and the cube root of 125 is just 5. And now we can take questions that are connected from our first unit and our second unit together. So I'd like you to try this one on your own. Draw a picture of the cube. By the way, if you want to know how to draw a picture of the cube, start with a square. Then pick an angle. And we know that the volume is 4,913 cubic inches. That's how many cubes of about this size would take to fill the whole thing up. You need to figure out the surface area. How much would it take to paint the whole shape? Do some problem solving, talk with a neighbor, come up with a strategy. This is a bit of a problem solving question because it's not direct how you would solve it. So if you have a problem solving question, you would write out some things that you know. For example, volume is length times width times height. And because these are all the same, I'm going to call one side S for the side length. Does it make sense that the volume is going to be S cubed? I want to find surface area. So often with surface area, we opened up the shape and added up all of the sides that you have. Do you see that for the surface area, there's going to be 6 sides that are all the same because it's a cube. There's 6 squares, and the area of a square would be S squared because I have one side length. So in a problem-solving question, sometimes the first thing that you're doing is just putting down information that you know. Okay? I want to find the surface area. If I want to find the surface area, I have to do 6 sides squared, so I need the side. Do I have the side? No. So just starting, if you just tried to solve the question directly, we'd run into a problem. What else do I know? I know the volume. So I could write in this formula that the volume, 4913, is equal to S cubed. If I could write the 4913 into 3 things, then my life is going to be easier. Does this one work out nicely without a calculator? Can you see that you can't divide 4913 by 2? Okay? Can you divide it by 3? No. Does everyone know the trick for checking if something you can divide it by 3? If you add up the numbers, 4 plus 9 is 13, plus 1 is 14, plus 3 is 17. If you add up the numbers and the number that you get can be divided by 3, it means your whole number can be divided by 3. The same is true for none. But this one doesn't work that way as well. Okay? If you had this test on a quiz, this question on a quiz or on a test, you'd have a calculator. So at this point, do you see that it makes sense to cube root 4913 to see what we would get? And does it work out to a nice number? Yes? Okay, then I'm trying to do some mental math right now, figure it out. Is it 17? So the cube root of 4,913 is 17. And if you have that now that we know S is 17, we can now figure out our surface area. Is going to be 6 times 17 squared, which, again, probably need your calculator for. I don't know. Is it something like 17 something? 1724? 34. Oh, so close. Do they have units in this question? Cubic inches? So this being a surface area will be inches squared. Oh, I'm almost done marking your test. Not quite. And you guys are getting so much better at making less unit mistakes and less rounding mistakes. Some of you love to make rounding mistakes, so you'd like rounding. I have to write rounding so many times. I only took off half a mark once. If you make 2 or more rounding mistakes or 2 or more unit mistakes, but I've been very impressed with how you have been improving in that. Okay, so there is homework listed there. I'll stop a video right here.